Now here the question is, we'll need to solve this integral in which parameter is a. So we'll write fa equals this integral from 0 to infinite e to the power minus x upon x and then a minus 1 upon x plus 1 upon x into e to the power minus ax into dx. Now again we'll differentiate this function with respect to a. We'll write f dash a as this integral from 0 to infinite, and now we'll partially differentiate this function with respect to a. So it'll be e to the power minus x upon x, derivative of a will be 1, derivative of 1 upon x is 0, then it'll be 1 by x, and here will be e to the power minus ax into minus x dx. Now here x and x will cancel, so we'll write f dash a as this integral from 0 to infinite e to the power minus x upon x and then 1 minus e to the power minus ax dx. Still this integral is not in the solvable form, so what we'll do is we'll differentiate it once again. So we'll write f double dash a and it'll be equal to this integral from 0 to infinite. Again we'll partially differentiate it with respect to a, so it'll be e to the power minus x upon x and then minus e to the power minus ax into minus x dx. Now here x and x will cancel, so we'll write f double dash a as this integral from 0 to infinite e to the power minus 1 plus a into x dx. Now if we integrate this function, we'll get e to the power minus 1 plus ax and then upon minus 1 plus a, this integral from 0 to infinite. So we'll write f double dash a as, now if we put x as infinite, it will be e to the power minus infinite, and e to the power minus infinite will be 0, and then e to the power 0 will be 1. So this f double dash a will be 1 upon 1 plus a. Now before solving this differential equation, we'll find some initial values. If we put a as 0, we'll write f0, and here will be minus 1 by x, and e to the power 0 is 1 plus 1 by x, so it will cancel. So value of this integral will be 0. So when a is 0, value of this function is 0. Now we'll also put a equals 0 in f dash a. So it will be f dash 0, and here it will be 1 minus e to the power 0 is 1, so it will be 1 minus 1, which again is 0. So from here we'll say value of f dash 0 is also 0. So we have two initial conditions, and they are when a is 0, f is 0, and when a is 0, f dash is also 0. Now we'll integrate this function with respect to a. So we'll get f dash a equals log 1 plus a plus c, and if a is 0, f dash is 0, so it will be 0 plus c, that means value of c is 0. So we can write f dash a as log 1 plus a. Now we'll integrate it again with respect to a. So we'll write f a, and here it will be this integral log 1 plus a dA. Now what we'll do is we'll let 1 upon a as t, so it will be f a log t dt. Now integral of log t is t log t minus t and then plus c. So we'll write f a as, now t here is 1 plus a, so it will be 1 plus a log 1 plus a minus 1 plus a plus c. Now if a is 0, it will be log 1 0 and then minus 1 plus c, that is value of c is 1. And if we put c as 1, the c and minus 1 will cancel. In that case, value of this integral will be 1 plus a log 1 plus a minus a, and that is the answer to this question.